So 331, we start to talk about domain and range. So the domain of a function is the set of all the values it will accept as inputs. Your range is the function is the set of all outputs. Sorry, that should say of all values. That's a typo in the notes. The range of a function is the set of all values it will return as outputs. So, and you may also recall this, that our domain is our x's and our range is our y's. X's are our inputs, y's are our outputs. So there's a couple different ways we can find the domain and the range. So starting with a mapping diagram. Remember, a mapping is the one where they have the two circles and the arrows drawing from one to the other. So to use a mapping, to find the domain, you find all the values in the left oval that are connected to arrows. That's very important, okay? That are connected to arrows. So what that, and I'll go ahead and explain the next part, and then I'll explain what that means. To find the range for mapping, you find all values in the right oval that are, again, connected to arrows. So a really easy example, if I were to draw two ovals, and I put the numbers 1 and 2 in the left one and 1 in the right one, and I drew an arrow from 1 to 1. What that would mean was that 1 is in the domain, but 2 is not in the domain, even though it's in the left arrow, because it does not have connected, or because it's in the left circle, but it's not connected to an arrow, so that means it's not actually in the domain. 1 on the right would be in the range because it does have an arrow connected to it. All right, our second way to figure out what our domain and range are is using ordered pairs. Remember, ordered pairs are going to look like this, x comma y with parentheses. Our domain is all of the x coordinates, and our range is all of the y coordinates. The last way to do it is to use a graph, and we'll do some examples of that in a second. To find the domain in the graph, you study, again, all of the x values, and to find the range, you study all of the y values. So we have some examples here. Number 3 says to find the domain of each function. So our domain in this case, remember, this is called a mapping because it's got the circles. And to find it from a mapping, we look at everything with arrows connecting to it, which means 1 is not in our domain, but 2, 3, 4, and 5 are, because they all have arrows attached to them. And we're supposed to find our range. So look at 4 is not in our range because there's nothing touching it. 5 is in our range. Even though there are 2 arrows going to 5, we still only write 5 one time. 6 has nothing touching it. 7 and 8 do, so 7 and 8 are both in our range. Remember to find the domain in an ordered pair. Ordered pairs are in the parentheses with x then y. X's are our domain, and our y's are our range. So that means to find our domain, we are going to look at the first numbers in every parentheses. So that would be 1, 2, 5, and 6. That's going to be our domain. And then our range, we look at our second numbers, which would be 4, 7, 1, and 3. Typically, you write them in numerical order. So I'm going to go ahead and do that. So I would write 1, 3, 4, and 7. It would not be incorrect if you just wrote them in the order you see them in. So you could write them like this, 4, 7, 1, and 3. It's just not the most correct answer. All right, so the next thing says to estimate the domain and range of each graphed function. So for this section, we're supposed to find the domain and the range from a graph. Now, it is a little more complicated to find it from a graph than it is to find it from ordered pair or table. So I'm going to go to the end, and I'm going to add in a blank page, and I want you to write some of this stuff down somewhere on the notes for this section. All right, so we're talking about finding our domain from a graph. And we're also going to talk about finding our range from a graph. Okay, there's 2 phrases I want you to remember. For domain, I want you to remember the phrase Lord. Okay, and this will help you remember how to read your domain. That's what the D in Lord stands for. To read our domain, we read our graph from left to right. And that means that we're looking for the left side of our graph and the right side of our graph. And we're going to put this into practice in just a second. Don't worry. For our range, I want you to remember the phrase robot. Okay, the R in robot stands for range. And our range goes from bottom to top. Okay, so our range we're going to read from the bottom of the graph to the top of the graph. For our domain, we're going to read it from the left to the right. So I'm going to go back to those problems. So we're supposed to find the domain and the range. We're going to start off with just finding the domain. So remember, our domain we read from left to right. So that means I'm looking for the left side of my graph and the right side of my graph. Well, if I had a graph that looked like this, then it very clearly has a left end and it very clearly has a right end. I have a parabola. If you think about a parabola, there should really be arrows here that show you this graph continues and keeps on going. Well, if my graph is continuing, then all it's going to be doing is getting wider and wider and wider and wider each direction. So that means it never stops. And in this case, and this is true for all parabolas, okay, all parabolas, every single one of them has a domain that is infinity to positive infinity. Or we can also write it as all real numbers. That's another way we can write that domain, is all real numbers. And again, that's true for all parabolas. Our range is going to be a little bit different, and we'll come back to that in a second. Okay, so let's look at our next one. This is a cubic graph. So if I were to draw arrows at the ends, what's happening is my graph is just continuing to get wider and wider and wider. I'm looking at it from the left to right again, just domain. So the same thing is true, that it's going to continue to get wider, so its domain is going to be all real numbers. Okay. All right, and then if we look at our last one, our domain, again, there should be arrows here, and this one's a little bit easier to see. When you see something like this, what this means is that the graph is, again, going to continue to go. There's no arrows drawn there, but they are going to continue. And so its domain, again, is all real numbers. Okay? Anytime you have a cubic, like this one, its domain will always be all real numbers. Okay, so we're going to talk about our, range now. So range, remember, if you'll recall, we read from bottom to top. So we're going to go from the bottom of the graph to the top of the graph. Now for a parabola, if I want to find the bottom of my graph, it's going to be down here at the vertex, or maybe the top of the graph. Okay, so in this case, my range does have a bottom value. My range is, it starts at 0, and my graph, I figure out which direction it's going up, and it's going to continue to go up forever. So it goes from 0 to infinity. Or you could also say that it's all y's that are greater than or equal to 0. This notation is going to be the notation that is on your actual quiz. So it's going to be y's greater than 0, because 0 is the bottom value. Okay, so when I start looking at my cubic, I'm looking for the range, so I'm finding the bottom of the graph and the top of the graph. Well, remember we said this graph is going to go forever and ever and ever and forever and ever and ever. So that means its range is going to be all real numbers, because it's just going to go on forever and ever and ever. Now, this particular graph here, this third one, its range is a little bit easier to find. So we're looking for the bottom of the graph and the top of the graph. Well, these little dashed lines here are called asymptotes, and we'll talk about those in semester 2. So you don't need to worry about learning that now, but what you need to know is they actually tell you what the domain and the range are, depending on which direction you have them. Because what this line means is that the graph cannot go below that line. So that means our range starts at -1, and it goes to +1, and it's our range, so it's our y's, so we're going to write it like this, that our graph, our y's, are between -1 and +1. So how to use a function, how to use an equation to find the domain of a function. What you have to look for is you look for any x values or input values, either one, that the equation will not accept. So for example, if I have f of x equals 1 over x, well, the rule in math says you cannot divide by 0. That's just a rule. That's always been true and it will always be true. So that means that 0 cannot be an input. So what we would say is that the domain is every single number except for 0. And you can write it like this as well. All right, when I want to take the square root of x, well, I cannot take the square root of a negative number. I can't try the square root of negative 25. It doesn't exist. And so that means I can't put anything in here for x that is negative. So that means that any negative number cannot be an input. So the domain is all positive numbers. And we can write that as x's are greater than or equal to 0, because everything that's positive is greater than or equal to 0. I'm going to do the odds on the practice problems, and you'll be responsible for doing the evens. So it says number 1, we're going to determine the domain and range of each function. So remember, our domain we get from this box over here, and we want to look for everything that has an arrow attached to it, which would be 1, 2, 3, and 5. Our range we're going to get from the box on the right. Range is on the right. And we're looking for everything that has an arrow attached to it. Well, that would be 8, 12, and 22. So 15, even though 15 is in the box on the right, because there's no arrow attached to it, you don't actually put it in the range. So that one is out. All right, looking at 3, I'm supposed to find the domain and the range of the graph. So recall for my domain, I'm reading it from left to right. So I'm looking for the left side of the graph and the right side of the graph. Well, there's arrows there for both of those, so that means it's going to go on forever. So my domain is going to be all real numbers. Okay. For my range, I read my range from bottom to top. So again, I'm looking for the bottom of my graph and the top of my graph. Well, here's the lowest point on the graph, and there's an arrow. Here's the highest point on the graph, and there's an arrow. That means it's going to go on forever. So the range is all real numbers. If you look at number 5, so I'm going to find my domain, which my domain, again, I read from left to right. So I'm looking for the left of the graph. Well, this time the left of my graph is right here. The right of my graph has these arrows. Okay, so since my left of my graph has a number, I'm going to write that number down. I've got to figure out that x value. Pay very close attention to how these are counted, because this says negative 10 here. It doesn't go negative 1, negative 2, negative 3, negative 4, negative 10. Each of those represents 2. So the left side of this graph, that value is actually at negative 7. Okay, and the graph is to the right of that, so we're going to say our x's are greater than or equal to negative 7. That's going to be our domain. For our range, again, we read from bottom to top. Well, the bottom of my graph is here, there's an arrow. The top of my graph is here, there's an arrow. That means it's going to go on forever, so it's going to be all real numbers. Okay, looking at 7. All right, so the bottom of my graph. Well, the lowest point on my graph is here. It doesn't keep going down. It goes down to there, there, there. So that looks like, to me, it's going to be the bottom point of my graph. And then I have there's the top. It doesn't look like it goes any higher than that. So that means that my domain actually has numbers. I'm sorry. Let me try that again. Our domain, we read from left to right. I'm sorry. So our domain, we're looking at the left side, which would be over here. Doesn't have an arrow, but it should. And we're looking at the right side. Doesn't have an arrow, but it should. So since it has arrows at the left and the right ends, it's going to be all real numbers. For our range, we're looking at the bottom and the top. Well, here's the bottom of my graph, as I said earlier. And here's the top of my graph. So that means this time my range actually has numbers. So the way we're going to write this is we write the lowest number, which it looks like it's at -4. And we write the highest number, which it looks like it's at positive. Oh, I apologize. These are not by 2s. These are counted by 1s. So the bottom's at -2. The top is at +3. Since I'm talking about my range, I'm talking about my y's. And I'm going to put less than or equal to signs in the middle. So that means that it's my graph, if my y's are between -2 and 3, or my graph is between -2 and 3 vertically. All right, last question, number 9. Looking for my domain and my range. So domain, we read from left to right. Okay, so the left side has an arrow, the right side has an arrow. So it's going to be all real numbers. Okay, with one exception. This line right here is an asymptote. What that means is the graph can never equal this value. Okay, and that asymptote is at -2. So that means that our domain is x is all real numbers except -2. Okay, my range, I'm looking at the bottom of my graph, which is here, and I'm looking at the top. Oops, sorry. Let's try this again. The lowest point on my graph is here. The highest point on my graph is here. And they both have arrows, so that means that my range is going to be all real numbers. And there's nothing that stops this graph. It just goes on. There's no asymptotes, horizontal asymptotes this time. So that means it's not going to affect anything. So our range would just be all real numbers.